Good afternoon everyone, and thanks for joining us for our latest Oxford Sparks Facebook Live. What's particularly special about this one is that we're teamed up with Oxplore, a new digital outreach portal from the University of Oxford. It's the home of the big questions and can be found at www.oxplore.org. It's aimed at engaging 11 to 18-year-olds with debates and ideas that go beyond what's covered in the school classroom. Today we're asking a question that's based on one of these questions from the Oxplore site, and we will be posing it to 3 researchers from the University of Oxford. Today's question is, can you make something from nothing? To answer this question, we're delighted to be joined by Professor David Clifton from the Department of Engineering Science, Jena Meinecke, who is a Junior Research Fellow in Physics, and Minh Tran, who is a DPhil candidate in Organic Chemistry, all at the University of Oxford. So as well as exploring this fascinating topic, this is your opportunity to ask our academics questions about their research. So please write your comments below and we'll endeavour to respond to them. To start with, we put the question to you, David. So can you make something from nothing?
Brilliant, thank you, Sarah. Prediction is very difficult, especially about the future. That's one of my favourite quotes from a famous scientist, and that really describes what the research is that I do in my lab, which is machine learning. So you asked the question, making something from nothing. That's literally what we're dealing with on a daily basis, just pure information. So in the department here in Oxford, we're called information engineers. So it's engineering, we're constructing and building things, but it is out of something intangible, it's out of information. And to give you an example of some of the things that we build out of nothing, a lot of what we do is in healthcare. So, for example, trying to take lots of data from patients in hospitals, maybe wearing sensors. You might have got, for example, a Fitbit that you're familiar with. You've been collecting lots and lots of data about your body. When a patient's in hospital, there's loads and loads of different kinds of data of that kind, from wearable sensors through all the different kinds of technology that's monitoring a patient in a hospital. And the idea there is, can we build a system that predicts what's going to happen to the patient before it happens? So wouldn't it be great if we could get a medic to the bedside before a patient has a very serious emergency? And that's an example of one of the inventions that we've created in our lab. So these are systems that predict the future, but it's not as mysterious and magical as it sounds. What is it based on? It's based on statistics. So statistics is obviously that branch of mathematics you can study at school, which I'm going to say is often not taught in the most exciting way. Certainly when I was at school, people thought, statistics? Come on, how interesting is that? But it leads into artificial intelligence and machine learning when you're at university. And it really gives you the tools to be able to make predictions, to take loads of data from patients and to be able to make predictions about them and to be able to get a doctor to the bedside before something happens to the patient. As another example, loads and loads of data are being collected from hand pumps in rural Africa and Bangladesh, places where the rural poor don't have access to clean, safe drinking water except via a hand pump. So it's a very manual job pulling water out of the ground. And there the idea is, can we put some sensors, just like wearable sensors, some sensors into the hand pumps, collect data from the hand pumps, and there, again, make predictions. Is the hand pump going to break? And if so, can we get somebody to stop the hand pump breaking before it does? Because if a hand pump breaks in Kenya or in Bangladesh, it could be 20 miles to the nearest safe water source. So you can imagine it's a really big deal. And there are companies that we've set up, not-for-profit companies in Kenya, that are actively doing this. So we're recording data from pumps, making predictions about the life of the pump and the health of the pump, and bringing that mechanic to the pump to save the village's water supply. So these are all really fascinating examples of what you can do with nothing, what you can do with pure information in a computer.
That's fantastic. Thanks so much, David. So if you've just tuned in, we're asking the question, can you make something from nothing? What do you think, Jena?
All right, great. Well, thank you so much for the question. If you were to ask my mom, anytime we get into a disagreement, she says I'm the master of making something out of nothing all the time. But on a more serious note, from a physics point of view, in terms of the physical world, I think physicists are really fond of our laws. And one of the more important laws is conservation of energy. And at the end of the day, that states that energy can neither be created nor destroyed. It can be changed from one form into another. And in that sense, in answering the question, can you create something from nothing? From that point of view, you would say probably not. And so what you can do, though, for instance, is create new phenomena by transferring energy from an unlikely source of energy to another. So let's say, for instance, in our group, we study something called magnetogenesis. And that is the study of the origins of magnetic fields in our universe. And the prediction is that after the creation of the universe, magnetic fields didn't already exist. They came into existence at some point. And so then at some point, they were created out of what you might think of as nothing. But in actuality, the energy was transferred from one object to another. So if you were, for instance, to look at the early universe, the formation of our early universe, you would see a number of shock waves being generated everywhere. And these shock waves bring with them these magnetic fields, these primordial grandparent magnetic fields, which are created by transitioning kinetic energy of the shock wave itself into magnetic energy. And so in that way, you can create magnetic fields using a transfer of energy. And so that is called magnetogenesis. So we study that using really big lasers. In fact, some of the biggest lasers on Earth. It's quite an exciting job. I get to travel around, especially to California, sunny places like today, and fire really big lasers to recreate these grandparents' primordial magnetic fields. And so that would be kind of the closest way of answering how you can create something from nothing while still preserving the fundamental laws of physics.
That's really fascinating. Thanks so much, Jena. So if you've just joined us today, we're asking the question, can you make something from nothing? And I'd like to put this question to Minh. What do you think?
Thank you, Sarah. So as any good scientific inquiries, we need to define what we mean by something and what we mean by nothing. So in terms of an organic chemist like myself, the something we're interested in is interesting compounds, interesting molecules, which are interesting because they have very good therapeutic activity, such as anti-cancer or antibacterial, or they're interesting because of their structures are challenging and requires new methodology developed in order to make them. So that sorts out the something bit. The nothing, if we define nothing as simply the lack of molecules or atoms, then the answer is simply no. You can't make molecules without molecules, which ties into what Jena just said about conservation of energy, goes for the conservation of matter as well. So if you imagine a chemical reaction to be the same as baking, then your desired product will be, say, a sponge cake. Then you need to add into the reaction mixture the correct amount of starting materials such as flours, eggs and sugars in the right addition order, and then you had to subject it to correct reaction conditions such as baking at 120 degrees or for 45 minutes, for example. So through the reaction then progress, and then you can transform the starting materials to change into what you want at the end. So basically a reaction, a chemical reaction, is most of the time a breaking of already existing bonds and forming new bonds between the atoms you've already added into the reaction mixture so that they rearrange their conductivity and form your desired molecules, which is what I'm doing in my research project at the moment. I'm trying to synthesize a natural product called obscurinine, and it has very interesting therapeutic effect, but it hasn't been studied in details. So I'm hoping that by a series of chemical transformation, I can make this final natural products from simple building blocks. So from a pragmatic point of view, we can safely say that you can't make molecules from no molecules. But chemistry is not just about making reactions. Chemistry is also about innovations and coming up with new problems to push our understanding. And in that case, if we now define something as a scientific project and nothing as just a simple, discardable, throwaway ideas, then the answer is positively yes. Most of the time, a new project is started because someone just discovered side products they hadn't expected before, or simply because they just wondered what would happen if I did this. So yes, from a very simple throwaway idea, you can kickstart a whole new avenue of science that you can explore and tap into.
Fantastic. Thanks so much, Minh. Some really fascinating insights. It's been really interesting to speak to each of you today. If you do have any questions, if you post them up, and our team will endeavour to get back to you. But just to say thanks so much for joining us today, and we really hope that everyone listening has enjoyed it as much as we've done creating it. So thank you.